When it comes to our exploration of the solar system, one of the most dangerous aspects of space for the human body is cosmic radiation. But for a totally different kind of living thing, cosmic radiation could actually be a source of life. This is according to a new study which suggests life on other planets might survive on the energy provided by cosmic radiation. The findings open up the possibility of finding alien life forms on planets we previously thought were uninhabitable. Astrobiologist Dr. Dmitry Atri from the Blue Marble Space Institute of Science in Seattle was inspired by an organism found on Earth. The rod-shaped bacterium called Asulfurottus odaxviator lives 1.8 miles underground where there is no light, carbon or oxygen. This strange bug gets its energy from the radioactive uranium found in the mine. It really grabbed my attention because it's completely powered by radioactive substances, Dr. Atri told Science. Who's to say life on other worlds doesn't do the same thing? The Earth is constantly bombarded by high-energy particles like protons, electrons and atomic nuclei. These particles make up the so-called cosmic radiation, and they originate from huge explosions in dying stars called supernovae. But our planet's magnetic field and thick atmosphere prevent these dangerous particles from entering and affecting life on the planet. Many other planets do not have the same kind of protection, and these kind of worlds have previously been ruled out in the search for alien life. However, the new findings published in the Journal of the Royal Society Interface could change what kind of planets we search on. It's funny, Dr. Atri told Science, because when we look for planets that contain life currently, we look for a very thick atmosphere. With these life forms, we're looking for the opposite. To test this theory, Dr. Atri ran simulations to see whether small organisms like the bacterium could live off cosmic rays on Mars, the Moon, Pluto, Europa, Enceladus and some comets. The rays striking a planetary surface in these environments would produce secondary particles which could be capable of producing the energy to do things like split water. This would provide a potential food source for any tiny life forms living underground, where they would also be shielded from the worst of the radiation. But they would have to be extremely small and have slow metabolisms to survive with this as their source of energy. The total energy in cosmic rays reaching the surface even of an airless body is tiny compared to the level of sunlight that reaches the surface of the Earth and is used by photosynthesis. Dr. Chris McKay, an NASA astrobiologist, told Popular Science, the amount of cosmic radiation hitting the surface would have to be just right, as too much or too little could kill off this kind of life. Life forms like this want a steady flux of energy from cosmic rays, but not so much that it's damaging. Astrobiologist Duncan Forkin from the University of St. Andrews told Science, they might not be able to cope with a huge bout of radiation. Dr. Atri will now look into how high-energy X-rays from a particle accelerator would affect Asulfurottus odaxviator. This is the closest we have to simulating cosmic rays in the laboratory. If the bacteria can survive, it could open up a new world of possibilities in the search for alien life.